Testing.
Mhm.
Hello everyone. Can you hear us? Selam arkadaşlar, selam herkese. Okay.
Welcome everyone. We will be starting our stream soon.
Arkadaşlar öncelikle bir uyarı geçeceğim. Tüm yayın İngilizce olacak. Sorularınızı Türkçe sorabilirsiniz. Ben de İngilizceye çevireceğim. So, welcome everyone. Today we are going to make an introduction to AI. We are going to look how it's made its evolution throughout the years. And as we know, the AI is becoming bigger and bigger in our lives. So today I'm with Musab Khan, our member in project team, and also a graduate research intern. Welcome, Musab.
Thank you very much. It is a great opportunity for me to share my insights and my learnings with all the participants here. Thank you for inviting me.
I couldn't hear your voice. Sorry. Can you say again?
Can you hear me now?
Yeah, I can hear now. Sorry.
Yeah. Yes. So thank you for giving me this opportunity where I can share my insights and learnings to all the participants here. And in this presentation, we will be going through these topics and gain a deep understanding of AI.
All right, so let's start.
All right. So starting with our first developmental stage of our current technology, artificial intelligence is gaining popularity in our recent times. We have been listening the rise of ChatGPT and several Google created algorithms and chatbots, which include Gemini, Bard, Google AlphaGo, etc. These all have been gathered and put under a single term known as artificial intelligence, which is a bit unclear or ambiguous term. In this presentation today, we will be uncovering all the internal components of artificial intelligence. We will be seeing all the evolution and what does artificial intelligence means and the applications of it. Myself, I am pursuing masters in artificial intelligence at İstinye University. So starting with our first component of our topic, let's question what is intelligence. So, in our daily life as humans, we perceive the world, we learn and adapt, and we make the decisions in the world. We fail in few decisions, we succeed in few decisions, and eventually, through trial and error, we learn how to navigate throughout the world. And in the intelligence, the core capabilities include perception, which is seeing the sensory input and recognizing how the things work, recognizing how cause and effects operate in the world, like if you do this thing, what happens, and learning from previous experiences and gaining knowledge, then adapting to changing environments, and in the recent times, due to changing weather conditions, environment conditions, health conditions, technological states, and all so on, human beings have been adapting throughout the history, and we have this capability where we are very good at adapting to different environments. Then we also have the skill of problem solving, where we in a team work and solve several challenges and find the solutions. Also, we act based on reasoning, and we pursue good decisions and discard the ones which don't work after we use an approach of trial and error. So these are the core components of intelligence, and this is how we navigate this world and grow ourselves in this world. Now, what is artificial intelligence? Let's delve into this question. Now, AI, in this term, there is artificial and intelligence. Here, intelligence, I have described it as perceiving the world and reacting to it, making decisions. Now, this was all done by humans. Now, artificial term includes something which is created by man. In several fields, you hear the terms such as synthetic, man-made, etc. It is the same terminology wherein man is creating some systems, or human beings are creating some systems or machines that simulate human intelligence to perform tasks. We aim to achieve machines and frameworks that can learn, reason, perceive, and act based on their learnings from their world. Now let's cover different types of AI. Firstly, there is a narrow AI, which is AI which is built for particular task. So this type of AI is not good at everything. It is trained on a particular subset of data on a particular problem, and it is good at solving that problem. So this is the AI which we see in our world around us. And in the second type of AI, which is general AI, it is an AI that is believed that it will be such that it can learn, understand, and apply the knowledge across various domains. So it is thought to be included. It is thought to be having as a capacity to integrate several domains and make decisions, apply knowledge, and solve the current problems and proceed. Now, this is actually the long term of AI research, and it doesn't. We haven't been able to achieve it yet.
So
Now,
I want to ask a question right there.
sure.
Um, Nowadays we are using ChatGPT, Gemini,
Mhm.
DeepSeek, etc., etc. Which category does these fall in?
Yeah, these AI elements such as ChatGPT, Gemini, they all actually transcend narrow AI, and they are between narrow AI and general AI, because they can search the web, understand different websites, convert the text to say various formats, understand images, generate particular things. We have seen the advancement of AI, so we cannot categorize them as strictly narrow AI, because day by day, by the developments of it, we can see that it is increasing its capabilities in mathematics, coding, reasoning, creative tasks. So it hasn't reached general AI yet, but we can say it is between narrow AI and general AI, more leaning towards narrow AI.
So it's getting closer and closer to the general AI, as far as I
Right.
can. Okay.
It is still far away, but that is the current research motivation for several researchers, where several domains are thought to be integrated and create AI based agents. So, this is the current aim of our research, and we have active research papers being published where such general AI is hoped to be achieved in the near future. All right, now proceeding with narrow AI, let's see what in depth is narrow AI. So narrow AI, as we have came across in the previous slide, it is an AI which is trained on a particular task. Now, the examples of narrow AI could include AlphaGo. AlphaGo is an interesting development in the model where it has defeated a world champion in the popular board game known as Go. So, this surprised the whole world and introduced the capabilities of AI and what it can achieve. So, it inspired a lot of people to pursue research in this field. And we have been seeing latest models creating benchmarks in mathematics, coding, and protein folding, structure predicting, and modeling, etc. Then there is this voice assistants, which are commonly integrated in smart homes, such as Siri, Alexa, and Google Assistant, which understand our voice commands and respond to it. So if you are like, let's say, half an hour away from your home, you can make a command and say, please turn on the AC air conditioner so that the room will be cool. So this Alexa, Siri, such assistants help us making our life more comfortable. Then there are recommendation engines, which you can browse in the Netflix and Amazon. They usually recommend products based on what you have liked or what you have purchased earlier. Then there is this facial recognition, which unlocks the phones as you see your face. It extracts the your eyes, your nose, the whole geometrical representation of your face, and unlocks the phone. Now has been upgoing research on self-driving features where AI is thought to replace drivers or at least assist the drivers. So all these capabilities are termed under narrow AI. Also, like the AlphaGo had this interesting breakthrough with it, defeated a human, and this has gained a recently interesting, influx of researchers in advancement of AI, where they are thought to be helping humans in several tasks. One more interesting fact is these smart assistants don't actually understand the meaning. For example, they don't know as in the meaning in form of like how humans know the meaning, but they just match the patterns as to what the query of the user is and produce the answer or optimize the solution based on it. Then proceeding to general AI, it is a hypothetical situation where AI is thought to think, learn, and solve problems across various domains. It is, thought to learn anything and not just limiting itself to one skill, but learning several things, applying various integrations to itself. Also, it has this potential for reasoning, planning, and adapting. In the recent times, Google has released the Deep Think model, which has advanced thinking capabilities. So they have been publishing that Google Deep Think is performing really good in gold medal in achieving gold medals of mathematics Olympiad. So there has been interesting developments produced by the Google its company itself. Now there is this fictional portrayal of AGI we see in several movies such as Jarvis, which has these capabilities of flying and detecting the enemies and detecting several like weather conditions and safety conditions, etc. This is just a hypothetical portrayal of AGI, which doesn't exist yet, but is thought to be predicted to be achieved nearly like maybe 10 years or 5 years down the line. Now let's move on to the next phase of our presentation, which is why artificial intelligence matters. Now, artificial intelligence is important because it helps us transcend our human limitations. Our human limitations include that we can't process the information in the world rapidly, and if we are faced with a huge and massive information or data, the machines outperform us. Also, they have this speed and complexity of processing the data and handling difficult jobs, which make them an optimal thing to invest our research capabilities and improve them to solve our decision making and enhance our innovation as a civilization. Now, in the AI, it is really fast in processing the data. We can see in the finance and stock market applications of AI. in per second, millisecond, there is a lot of data being ingested into the pipeline. So AI processes it, and it has this capacity to generate insights and make predictions on it. Also, in the domain of delivery for robots, or transcribing text, etc., which are thought to be complex tasks, but now they can run some scripts which can automate these repetitive tasks, and they can handle it far better. And we are also investing a lot of research in making robotics enhance several capabilities, such as there are like home cleaning robots which clean the houses, and we are aiming to increase the output obtained from the robots, so that they can help us in various tasks, such as repairing some vehicle, or assembling, or any general tasks like that, which saves us time and processes repetitive tasks. And lastly, it helps in complex decision making, and like it helps in challenging humans to get better. For example, in chess, you can see several humans practice with AI bots to improve their performance. So it helps humans augment their own cognitive abilities.
So the AI enhances human decision making, but instead of enhancing human decision making, can't we make AI to make decisions itself?
That is a good thought, and the limitation with that is there is this concern of security and biases and hallucinations. When like ChatGPT was released, it made a lot of hallucinations, and there are several models in the market which have a certain biases from the owner which has created. So if the owner pre-configures something, AI will give output based on that. It is logical to an extent to which it has been given freedom or it has been restricted. So it is facing these limitations of safety and ethical concerns, where there is a whole team which is collaborating across the world, which concentrates on making AI as safe and ethical for humans, so that it doesn't backfire, or it doesn't becomes a weapon killing robot or something like that.
Yeah, and recently I saw a news about Anthropic's AI cloud. Uh, when the AI thinks that it needs to survive,
Mhm.
it starts blackmailing the user that he's talking to. Like, for
Yeah, they.
example,
Yeah.
a software engineer talks to the AI and says that it needs to do something, unless and if AI doesn't do it, it will get killed. And then AI starts to blackmail on the things that it knows for the
Right.
user.
Right. It also self pities. For example, Gemini released the console app, and it says I can't solve these problems, and there are some I am wasting your time, etc. So it is having these configurations set up by the developers from the backend, which, like I said, they come under the control of the developers who is developing these models. So unless we reach a stage where this configuration is open source and people can agree that the AI isn't stealing their data, isn't harming them in their life, we there will be this conflict which has to be resolved.
And also, we talked about algorithmic trading.
Mhm.
So another question that comes to mind is that how do we ensure the data privacy and security in these finance systems when we are using AI?
Yeah, in these finance systems, particularly, there are like two main problems. One is speed and accuracy. Speed, because the data is coming at a very fast rate, and the data pipelines generally in a millisecond process lots of data. So they need this capability to handle this incoming large flux of data. Secondly, the accuracy is very important, and the model, they have been following a curve where if for example, the performance dips, the model is being trained, and it asks for user feedback, or it asks for the outputs, feedback of the output. And based on the feedback, there is this term called reinforcement learning, which provides feedback to the model and rewards and penalizes or punishes based on its generated output. So there are some terminologies associated with it, which rewards the models based on its correct prediction. And if it deviates from, or if it goes, for example, doing some unethical or unsafe or manipulative tactics, we can punish it and penalize those channels so that AI can be safe to use for general humans. All right. Now, proceeding with the evolution of intelligence, let's see how the intelligence has evolved. So, firstly, we see in the phase one, there has been rule based systems. In these systems, the humans used to explicitly write the rules, and the system doesn't use like it doesn't learn anything. It just follows all the instructions written by humans. So when the user inputs some data, it performs some calculations predefined by the rules and generates the output. We can see the real world example in the case of calculators or some expert systems such as medical diagnosis, wherein you define like 3 into 4 is 12, and like 3, you predefine that if the user gives two numbers, you need to multiply them and give the answer. Here the machine or system doesn't learn anything, it is just following the written instructions. Now, the limitations with this approach is that it cannot adapt to new situations. So, if you say 3 into 4, 12, 9 into 8, 72, it performs good. But if you, let's say, didn't configure for exponents and you say, what is 9 power 7, and it is not listed in the rules, machine cannot solve it. So, for new and unexpected situations, there is this limitation where it is not learning from the data and only infers from its rules. So in the phase 1, this limitation was considered upon, and in the phase 2, in the machine learning phase, this limitation was focused. And in machine learning phase, the systems actually learn from the data, so they don't rely on the fixed rules, but the humans themselves give the features, and they machines learn the patterns in the features. So, for example, I will take an example of spam email detection. And let's say in your email, you get a email as you have won a 1 million jackpot prize, and the human defines this type of email as spam. And let's say there is another email which says, pay your invoice or pay your electricity bill, which is non-spam, and human predefines these answers to the email types. Then the machine learning understands the patterns. Okay, the use of million, money, and the jackpot and something like that corresponds to spam. And the the words like your professor has submitted email, deadline, upcoming deadline, etc., these are more like non-spam. So here the machine is learning from the input features. So this is a better model compared to traditional programming. There are still the limitations that humans need to manually configure the features, and we need to properly define the features, such as we need to give the answers for a particular input. So this requires an extensive feature engineering, which is a term used in machine learning pipeline. And if important features are not handled well, the machine learning performance will degrade. So these are the limitations of phase 2, where the machine is still dependent on input features on a human.
So I want to ask something here.
Sure.
We talked about the AI learns about spam mails and non-spam mails
Mhm.
based on the upcoming mails, but we also don't we predefine rules that make AI consider that look,
Mhm.
this may be spam.
Right.
So like if this counts as, for example, an X status, sorry, if this contributes an X attribute, you can consider this as spam, but if it doesn't, you can consider this non-spam.
Right.
So in my understanding that my understanding tells that it's a mixed state. Am I right?
Yeah, there is one more concept known as supervised learning and unsupervised learning, where if you even don't define the spam and non-spam, what machine learning model can intelligently do is it will categorize all the spam words in one place, and it forms a cluster of that group. So jackpot, money, $1 million, and life-changing opportunity, something like that gets in one group, and some authentic integral like words like deadline, assignment, and courses, etc., they come in one group. And even without the target columns, the machine learning is algorithm is intelligent to separate them, and we can further create models based on this grouping. All right, then let's proceed to phase 3, which is deep learning. Now, the limitation which the previous machine learning phase had was humans were manually setting up the features. Here in the deep learning, the model itself learns the both the features, and it classifies the particular data into a category. So how it works is it needs a neural networks. We train a neural network on the data set. It extracts the patterns from the data. So let's say in an example, we give an image of a cat. The network or the model learns by going pixel by pixel. It says this cat, the ears of it, the hairs of it, the eyes of it, like the particular features of the cat are at specific locations, and the model learns that this corresponds to eye, this corresponds to hair, this corresponds to its maybe ears, etc. And the deep learning model can easily recognize upcoming from the upcoming images if there is a cat or a dog. Also in like voice assistants also, there is this technology where the model finds the patterns in your voice, and it can generate your voice. So there is this in Apple MacBook there is this technology of Siri, where it says that you repeat my prompts after me. So you say you give it its name and say model name, what is the weather today, model what is the time today, and model what is the current temperature today, etc. And the model identifies your voice, and based on that, the future voice is detected by your previous stored data. Now the limitations of this is because it is extracting everything from the data, it needs a lot of data. Also it requires a lot of computations and clusters and CPUs and GPUs, which are actually computationally expensive. Also one more thing is it is like a black box, which is you don't know the inner workings of the model. For example, if you input 3 plus 4, how is it 7? You know how it's working, like which rule it has, based on which rule it is generating this output. In the case of deep learning, you don't know which rule exactly it's operating upon. So this is what we term as black box, where we don't know the reasoning process of the model.
But don't we know the algorithms that is being used for training? Like, what exactly prevents us to learn how the decisions are made?
Yeah. So the interesting aspect of this is the model itself detects all the features from the image itself. We can configure the model, but we can't configure or we can't know which pixel the model is concentrating upon. So actually, to solve this problem, there is a new field upcoming which interested participants can search, which is known as explainability of AI, and it aims to get behind the reasoning of the model, and it answers the question like how the model is getting to a particular output in an image. How does it know this is eye, this is maybe hair? How is it focusing on this pixel and saying this maps to hair and this maps to eye? So this field of explainability AI is a hot topic, and a lot of research is being done to increase such methods to get the explanations and the reasonings behind AI's output or prediction.
But as far as I can understand, this is a new research area. So, are we seeing any practical results like
Yes, yes.
valid
Yes.
papers that explain these?
Yeah, we have several methodologies. I can list a few of them, such as there is this LIME and SHAP. LIME stands for Local Interpretability of the Machine Learning Prediction Models. And what it does is it says the percentage wise ratio, where if it outputs yes or no as a result, it says which features did it consider. For example, if there is a medical data set and the model says this patient has maybe a thyroid disease, we can know on which features, by seeing which features it has said that the patient has this disease. We can get an internal ratio or percentage wise understanding that it is emphasizing an importance to a particular blood test which is responsible for thyroid hormones release, such as TSH, T4, etc. So there are like Lyme, GradCam, attention maps, and saliency maps, etc., which are offering new ways to interpret models' output.
Okay, and also, which phase are we exactly in? We saw three phases.
Mhm.
Uh, and I
Sure.
mean, are there any upcoming phases, or we are just at phase 3?
Yeah, we'll be going through this table and answering your question. So for we covered rule-based phase where the model doesn't learn anything and it just outputs based on what the rules it has been assigned by the programmer. Now, here human defines the rules and there is no learning based on this approach. In the machine learning based models, the model learns from the data, it figures out the patterns, and the human manually assigns several features. Now, there is this limited adaptability in it, and in deep learning, it further solves this problem wherein human doesn't need to set anything. Apart from the data, it doesn't need to set explicitly define the features. It can learn everything from the raw data, and the machine figures out everything from the data, but it requires a lot of data and compute. So answering the question, in this phase we are generally in the phase of deep learning, where we are seeing and boom in several integration of deep learning in a lot of domains. For example, there is this integration of health, medicine, and AI. There is this integration of electrical engineering and AI, where AI is used to pre-process radio signals and pre-process several physiological signals and heart signals, etc. And there is this integration of finance and AI and etc. So all these domains are working upon deep learning, and there has been increasing research over generative AI and large language models, which we will be covering in the future slide. And this question will be answered in the upcoming slide. All right. Now I will be going through how I'm using AI in my project, which is I'm working in an lab as my graduate project, and we will be going through a video which explains it. So, in our project, we are trying to build a machine learning framework which will classify the diseases of the small babies, and the model will the model will assist the doctor in figuring out if a baby has a particular anomaly in their heart. So it uses medical images and transform them into several features, and the machine learning model makes predictions. So this is the video of my project. So these are known as DICOM dataset. They are like CT and MRI scan of several patients, and we have their information from the medical hospitals, which are supervised by our professors and doctors, to whom we are grateful for this opportunity to conduct research on this. So, 1 second. This is data preprocessing phase, wherein the DICOM files consist of spinal cords, chest area, and a lot of things which are not directly related to heart. As this project focuses on cardiovascular structures, which are heart structures, we aim to extract the positions and locations of the heart using a software known as 3D slicer. Then we try to segment it and make 3D models based on it. So these models are further cleaned and we can get 3D models from where we can extract several features such as measurement of aorta, measurement of the curvature of the pulmonary artery, and several features which help in getting a mathematical representation of a baby's CT scan. Now, there is this segmentation process where we are extracting the positions of heart from the DICOM file, but this process takes a lot of time. So this manual process takes a lot of hours, and we aim to use deep learning to automate this whole process to generate 3D masks for the patient.
I want to ask something right here.
Sure.
So we are making the model to generate a precise 3D masks, right?
Right.
But earlier on the slides, we also said that the AI is not good at things like asking 3 plus 4. So how does this concept differ from that?
Yeah, the concept of 3 plus 4 is a rule based system, and it is an early stage of AI. And this project uses deep learning model, and deep learning model automatically extract features. Now, this is a good question you have posed, wherein you can see the DICOM files here in the image, and the model can easily extract the features by learning on it. So you don't need to specify here that this is hard and this is don't focus on this area, focus on this. Like, the model automatically extracts those details, and this whole procedure comes under deep learning.
And it also tries to understand pixel by pixel, right?
Perfect, right. So it goes by pixel, and as humans, you can completely see the complete picture and gain an intuitive understanding. But in the case of models, they go pixel by pixel. They convert these images into numerical texts and understand that. So the whole reasoning process of the model happens in the form of numbers, right? Now, let's proceed over how the model actually learns. What is the input given to it? So there are two phases here in the AI pipeline, where we prepare the data for the AI, and here we train the AI. Now, focusing on the AI input part, we pair the scan, which is CT and MRI scan, which we obtain from doctors, and manually segmented masks. So these manually segment masks actually guide the model that in this particular scan, this region is hard, and please focus on this region. So this is the role of this manually segmented mask. Then this is the input phase of the model. So based on this mapping of scanning and masks, you can see the test scan here. Although this is just an example, but once you give this test scan, the model, after learning the mappings of scan and mask, produces an output which is a predicted mask. So here, these masks save a lot of manual hours which have been automated by the use of deep learning model, which saves a lot of time and adds a dimension where we are using AI to produce these segmented masks. So here you can see in this first phase, we create manually segmented masks. So these are the locations of heart, and we are saying the model, hey model, you will receive the CT scans of the patients, and these are the hearts. So just focus on these mappings between heart and the CT scan. Then what we do is to allow the model to focus more on the scan and the regions of heart. We do a ROI cropping, which is region of interest cropping, and we zoom in on the scans and the mask so that the model can learn better on the input data. These are the finalized image and mask pairs you can see, which will be used for training AI. So this is an important concept for people entering into AI field. You need to properly configure the AI files or the data set into particular folders such as training, testing, and validation. So the model is trained on the training folder, then it is validated on this files, and it is tested over another subset of patients on which it produces masks. And the model actually doesn't learn in one go. It has to be trained again and again. So we generally train for 1,000 epochs. Now you can see how this is known as ground truth mask, which is the manually segmented mask. And on the right hand side, these two images are the several predicted mask, which is closely resembling to the original ground truth mask. And so this is how we obtain the results from the model after training the model on the patient files. So we have achieved an accuracy of 86% as of now, and we are training the models and applying various approaches, and we are aiming to increase this accuracy week by week. And these are the results for unit model. One more model we are working on is VNet model, and it gives an accuracy of 82% as of now. And in the future, we are trying to combine UNet and VNet model to such that UNet and VNet models combination can solve each other's deficiency. So the errors produced by other model can be solved by the other model, which further enhances the accuracy.
I want to ask something right there. What is the difference between units and VNets?
Sure. The UNet and VNet differ in their architecture, and UNet and VNet specifically are trained for medical segmentation purpose. They have encoder and decoder layers, and there is not much difference in terms of the mechanism, which is the encoder decoder skip connections architecture itself, but there is brief difference over how the transformer themselves are configured. So the parameters and the hyperparameters itself are different in these two models, and the research background from these two models aim for particularly different purposes, but they aim to solve the problem of segmentation in medical imaging. Then at last, I would like to thank Tubitak project, Tubitak resource, Tubitak committee for sponsoring this project, and supervisors. We have Professor Shanol and Professor Femilda and the doctors and several graduate researchers and undergraduate researchers who have helped us in producing good results as far as the project's pipeline is concerned. Then we are operating this project in our İstinye lab, and it focuses on VR, AR, and medical stimulations. Also, they have projects related to robotics and human computer interactions. They have these social media platforms listed below where the interested participants can see which type of projects have been conducted in the lab. So this is the project which I am working currently. Now, going on to the later part of the presentation, these are the main AI subfields, and here in simple words, we replicate what humans can do, and we want the machines to do those particular things. Now, if machines can see, if they have that ability to see, they are classified under computer vision. Now, this comes as detecting several faces and maybe detecting cars on the road, and detecting several objects in the background or the road, etc. The machines can also read and write. So in the Google Translate and chatbots, they understand what humans are writing, and this comes under natural language processing field. Then there is this robotics field where machines act and perform tasks physically. Also, machines can reason, and there are several diagnosis systems which understand what the patient is saying and produce particular assistant tool for the doctors so that they can quickly from the symptoms understand the disease and help the doctor. Then there are like several AI models which help us create several content, and they come under generative AI. ChatGPT Gemini is an example of this. Also, chess AI and maybe logistics optimization platforms can plan ahead based on the patterns in the past. So for example, based on the past patterns, there has been variations in the stock, and let's say in these hours the demand for a particular product is very high. So the machines can give us insights that to handle such scenarios in future, to plan ahead, the stocks must be filled properly. So machines can usually help us in these particular domains. So the interested participants here can make a note of these subfields and can further explore their interests into which type of operating, like which type of machines or which domains they want to operate the machines in.
So I have another question.
Sure.
When we talked about NLP, natural language processing,
Mhm.
how exactly for example, Google Translate or chatbots understand what we write there? I mean,
Yeah.
sometimes we write things that may seem out of context for our texts,
Mhm.
but they are getting really good at
Right.
capturing the meanings. But how
Right.
exactly they do that?
So what they do is they convert the text, which is alphabets, into numerical representations. So for example, if you say translate the sentence "I am eating" in Turkish, what it does is it converts IAMEATING to numerical representations. Then it matches the closely representations in one group, and it generates the output based on the similar representations. So what it does is it doesn't understand the meaning of the word, but it groups the input into several representations in the space. So machine learning, it has like a 3D space. So imagine if you say generate an image of, let's say, pizza and Mars and maybe sun. What it does is it creates a representation for pizza for sun and earth or Mars, and it creates an image where it combines this representation. Even though this is fictitious and not possible, but due to this ability where it converts this representation from text to numerical type, and produce output based on this categorizing or grouping, it is successful in such understanding of the human text and generating or predicting the output.
But for example, a word may have different meanings when used on different sentences. So how AI differentiates this?
Yeah, there is this attention scores and context relevancy, which in simple words, the AI model is not trained on a small data set, it is trained on a large data set. So for example, a movie review section, maybe comment box, the model is trained on a lot of words. So if the user says not interesting, this for example, if the model had assigned interesting higher weightage, this would have been translated into a positive review. But when the model is trained on a lot of times, it understands the context of the sentence, and like non interesting or not interesting, it is automatically categorized into a predefined label. So not interested is interpreted as the user does not likes this particular movie or something like that. So what it does is, based on this large context and large pattern finding ability, it can easily, depending on context, figure out what is the optimal meaning or representation of that word. That is how it works.
So the main requirement is that we need huge data sets.
Right, you identified it correctly. We need lots of data, which helps the model in identifying the patterns and context. So the patterns and the context is the key here, where on the model produces the output based on it. So machine learning is not magic, it's just predicting output based on the patterns it has learned.
And I guess this makes the difference between a human learning and machine learning. I mean, for words or using sentences, in my view, humans can learn in an easier and a shorter way
Yeah.
than the machines.
Yeah, if some of our participants want to go deep into this, there is a concept of humans learn via causal relationships, like why and like cause and effect relationships, and machine learning understand via statistical methods. So it takes the input, it uses statistics to understand the meaning of it, whereas humans uses this causal relations, and not only limited to causal relationships, but they have this memory, genetics, and this intuitive understanding of the world, which helps them in gaining more meaningful context, which the machine learning model doesn't has. So it starts with zero knowledge, and it uses a statistical approach to gain sense of the input. Now, moving ahead, let's explore briefly the computer vision and NLP field. The computer vision field deals with teaching the machines to see and understand the images and videos. Now, in the picture in the right hand side, you can see the model is predicting or categorizing a particular object as a car, truck, person, traffic light. So, as the models are trained by, they can further, distill key information from a scenario and make decisions based on it. So if it sees that a person is walking by, maybe there is this learning in its inherent patterns that it should stop, or it should abide by some rules which it has learned. So this is how the computer vision tries to interpret the world. Now, the core tasks could involve classifying if an object is a particular animal, or detecting if there is a car in the image, or maybe segmentation, which is comes under medical imaging project which we just covered. There also, the model is going through the pixel, it is seeing the pictures, which is, it doesn't actually see in how humans see, but it converts the pixels into numerical format and understands it. So the main applications of computer vision are face recognition in smartphones, self-driving cars, and medical scan analysis. Now, coming back to natural language processing, its main goal is to make the machine understand human language. So humans understand the language and communicate, and we want the machines to get involved and understand the human transactions. So the core tasks here, like basic tasks which beginners can get started with, include sentiment analysis. So is the tweet or a movie or a product ratings positive or negative, or maybe translation from one language to another, or maybe from a particular text finding the main key places or people or key information. And for example, to give a better example, let's say you have a document of recipes, cooking recipes, and you don't have title. So there is this task known as topic modeling, where the model goes through all the words, forms an understanding of the whole structure, and gives a topic structure to this document. So this comes under natural language processing. The applications include chatbots, spam filtering, and voice command. Now, here we answer the previous question you raised, which is where is the current research actually at? So now, currently, we are, seeing the uprise of generative AI models that produces contents, and in the tabular format, we can see there is this, modality in simple words means different format of the input or the different format of the output. So the model can deal with text, it can deal with images, audio, and videos, and these are the like popular tools. And what it can do with it, like if you input the text to chat gpt, it can create creative stories and art, and maybe write some code. And it can, if you give a prompt, it can generate images and art, logos. And also there is this company 11 labs, which is really good, and it works over text to speech, which is, if I'm saying something or if I'm writing something, it converts into text. And this is TTS, which is text to speech. And there is this STT, which is speech to text. So this comes under audio. And there is this video, which is generating animations or video clips. Now there is this question of how do generative AI work. Now there is this huge field of transformers and LLMs, but if I go over through them briefly, they have these structural components known as transformers, which understand the sequence and the context of the data, and the model can learn the context and the representations of the data. So the interested participants can read a paper which is very famous in this domain, which is published in recently, like last 5 years. The paper title is "Attention is All You Need." So this paper delves deep into how the models and large language models output and understand the data. So currently we are seeing this influx of research in large language models, which is a narrow field under AI.
Uh, I have a question here. So, previously, when we were talking about computer vision, we said that they do classification, right? And in generative AI, they're creating images. So,
Mhm.
they're both focused on images. But
Right.
are they doing their work on the same way?
No, thing is, the main difference is here it is classifying the object, and it does not need to know what a car means. For example, it learns how to just classify if a particular image comes. But in the case of generative AI, it has to know what a particular prompt or a word means, so that when you type cat, it goes to what it has learned. For example, what does cat means? Like cat means an animal with 2 ears and a small size, and maybe colors, there are like several colors, etc. So the in the generative AI, the model usually knows a lot of things, but in classification it's a different mechanism, wherein it doesn't need to have such a deep representation. Also there is a representation involved in both cases, because they are based on machine learning and deep learning. But the classification doesn't need to have in-depth knowledge of representations of the data, like that. All right. Then going over through the applications of AI in the everyday life, we can see in YouTube and Netflix there is this algorithms which are monitoring you, and you can change these algorithms based on your interest. So if you say you are interested in sports and you consume such content, AI learns that this particular user likes this particular content, and it suggests those particular videos and clips based on what you like. So it's based on the smart understanding of the user. Then there is this Google Maps, which has cool features such as detecting traffic ahead and saying maybe there is this police ahead feature, and a lot of things. Also, we have covered voice assistants, which are an application of AI. In healthcare department, we are analyzing X-rays and MRIs. We're using deep learning models, which extracts all the features, and drug discovery and maybe predictive, protein modeling, which Google DeepMind is working upon. It comes under this, where it is predicting several protein structures. Even in finance, to handle the detection, if a particular transaction is fraud, or maybe if something is repeated in a high frequency way, the AI can is able to track it. So these are the like general applications of AI, which we are facing an increasing amount of integrations into the app. So in the like previous decade, we didn't had this type of integration of AI into our lives, but slowly as the time goes by and the developmental changes in AI, we are seeing every applications utilizing the power of AI, which makes it a necessity to understand the learnings and how the model works, and use this AI to solve several problems. Now, going on to this last slide, which is covering the in the picture, you can see which are the main fields. So the interested participants can go through these fields. They can see how AI is being used in the world, which types of problems are being solved in the world. So in the machine learning, there is this deep learning and predictive analytics. In the natural language processing, there is this translation of a language, classification and clustering, and also information extraction from the dataset. The speech system includes transforming speech to text and vice versa. There is this planning, optimization, and scheduling, which helps in logistics departments and maybe solving some mathematical problems. Then there is this field of robotics. Then there is this vision, and where it deals with images and videos. So these are the fields where the current ongoing developments are happening in the field of AI, and the latest papers are being published in these fields. Now, on the left hand side, we can go through the resources here. Now, in the GitHub repositories, there is this awesome AI, which lists a lot of libraries, frameworks, and papers in AI/ML. There is this awesome machine learning. So, this awesome here subtag has lots of, fields, not only limited to machine learning, but programming, computer science, and maybe some other fields. So users can explore these GitHub repositories. For deep learning and neural networks, like I have mentioned, there has been an increasing influx in research papers. So the papers with code website, it ranks the papers with the implementations of those papers. There is this system of starring, wherein users can, if the paper is really of high quality, users star it. So it helps you in reading the paper and going through it. There is this deep learning for coders, wherein fast AI, they have created a good platform, simplistic, beginner friendly platform, where people can get started with deep learning. Then there are some AI tools, which are a necessity in today's world. To know which types of tools are being released to the public, and to know a general knowledge of them, there are some repositories here which you can follow. And if you are interested in building your own AI apps, you can explore LangChain and Hugging Face. They provide custom models which you can fine tune and maybe use in your projects and build some AI stuff and use it to solve some cool problems in your domains. So that's about it.
Okay, then we can proceed with the Q&A part. There are some questions on the chat, so let's change the layout. Okay. So let's start with this one. How does AI help in detecting these heart anomalies? What's the basic idea? What kind of data does the AI system use to learn and identify these anomalies? So we talk
Yeah.
about this, but if you were to give a summary, how would you summarize it?
Yeah. So the AI model learns from the CT MRI scans, which are obtained from doctor, and the model quickly learns where are the abnormalities in the patient's structure, and it quickly, assists the doctor in finding the problems in the patient's heart.
Okay, on to the next question. Is there any risks in using AI in daily life, like with voice assistants or self-driving cars?
Yes, self-driving cars poses a high risk, and we need to, train the cars based on a high frequency of patterns. They should know the particular nuances where they need to follow the signboards, and where they need to slow down the pace and etc. There is this need to enhance the models and self-driving assistants more and more. As to voice assistants, there is the lesser risk, but they offer day by day increasing developments in the ecosystem, wherein you can search and discuss several features. The Apple ecosystem itself offers features like calendar, weather, and opening some apps, etc.
And I guess this is about your project. What's the next step for this technology? How do you see it evolving in the future? Are there any ethical considerations or challenges when using AI for such sensitive medical diagnosis?
Right. It's a good question. And here, for our purposes, we are in our last phase of a project where we are integrating machine learning model based on healthy patients. So we need to train the model to know to make it learn like how the healthy patient looks like and how unhealthy patient looks like, so that when giving an outcome, it can differentiate between a healthy and unhealthy patient. Regarding ethical considerations, it's a good question, and generally we anonymize the patient's data, and the model and all the informations is being, we remove all the patient's name, tags, date of birth, and all the personal information to retain and protect the patient's integrity.
Okay, another question. What exactly does early stage pediatric cardiology anomaly detection mean in simpler terms? Why is it so important to detect these anomalies early, especially in children? So
Yeah.
how can we simplify this concept? I mean, why it is important?
Yeah, this field actually deals with kids or babies who have holes or abnormalities in their heart, and if we don't detect these diseases in early stage, it could cause serious risk problems to the babies. And if we could develop a model which can assist the doctors in correctly identifying the root cause of a patient's problem, it can help, reducing the risk of increasing complexities in the baby's health. So this is how we, try to make the model learn and detect early the disease a patient has.
All right. Here's another question. Is AI meant to replace doctors or does it help them? How? Challenges and future. What were some of the biggest challenges you faced while developing this AI system?
Interesting question. AI currently does not have this ability to replace doctors. Currently, the motive behind AI is not to replace humans but to assist humans. So here the doctors will have their expertise, but to save time and, help them in their medical diagnosis approach, we aim AI to integrate into their workflows and make the repetitive or make some processes which AI is actually good at, such as predicting based on some outcomes or patterns. We want to delegate it to AI. Now, regarding the biggest challenges, we actually face this challenge of the limitations of dataset. So this research focuses on a subset of a patient, which is small babies, and that too babies with abnormalities. So the finding the data from private hospitals was a bit difficult, and more so finding healthy patients were even more difficult, because no one actually gives the data of healthy patients. because we already have the data for unhealthy, but no one actually produces the data for healthy patients.
So, are there any questions you want to ask, guys? Arkadaşlar, soru varsa alabilirim. Okay, here's another question. Can you give us an example of how this AI could help a real child? What advice would you give to someone interested in getting into AI for healthcare?
Yeah. So there are two aspects of this question. Firstly, how AI could help a real child. For example, if a baby has abnormality, I'm not taking the case of my project itself, but let's say they have this hypothyroid levels where you can, based on some parameters or patterns, you can detect if a patient has a particular disease or symptoms. Again, like I said, AI is not magic, but it is based on patterns. So if there are like huge amount of patterns available, AI is the best tool to employ for it. So, like for example, a hammer, a needle, a screwdriver is a tool, and we use it where it serves the best. So, in the data set or domains where there are like a lot of patterns, which in typical healthy or medical data set, there are like a lot of patterns available, where like abnormal patients have distinct patterns, healthy patients have a distinct pattern. So AI is really good at mastering those concepts. Now, people, for those who are interested in getting into this integration of AI and healthcare, the main challenge in today's era is about image pre-processing and using AI to clean the images, to increase the resolution of images, to understand the patterns. And earlier we had AI to for it to learn from textual data, but in these upcoming days we have these MRI scans, we have these input images, we have this lot of image in the data in the form of an image. So we need to develop more models which can accurately represent this image, learn from this image, and predict or understand or generate healthy or predictions, and give us meaningful outcomes which solve the problems.
All right, we have another question. As it is related to AI, how it can be used in healthcare, like most people are. I think we answered this throughout the other questions, but you can give an answer to this also.
Right. So, how AI is related with healthcare? So, mainly like these days, for example, if you say in the COVID example, there has been a consistent pattern with the patient's nose has been this, disability of smelling. There has been an increase in a particular blood test level and a virus when they are tested. So, all these things show a particular pattern. So if if a patient goes to the doctor and say all these symptoms, if we had this bulk amount of patterns which can quickly categorize a patient's symptoms and give potential solutions or potential disease categorization to the problem, the doctors could quickly assist and recommend a proper healthcare plan for the patient.
Okay, and uh, let's look our final question. Can we trust AI in healthcare?
That's an interesting question. Uh, if the question is posed such as, can AI alone handle the workflows of can it replace the doctors or can it replace the medical staff, then the answer is no. We can't trust it yet because it is prone to biases, and health is a pretty sensitive topic when compared to maybe translating documents, etc. So regarding healthcare, I think it's around like a couple of years or maybe 5 years down the line where we need more accurate models. And right now, the models we have at, it's good at just assisting the doctors, but not completely replacing the doctors. So we can't trust it 100%, but maybe we can correct it, we can offer it feedback, we can reward it, we can penalize it based on its outcomes or predictions, and increase the trust level in the AI itself.
And that was the final question. Thank you, Musab Khan, for joining this event. I'm glad to host you here and host this event. It was my pleasure.
My pleasure too. Thank you very much. I had a great insights by the questions of the people, how AI, like how there are several things we need to think when we are implementing AI, how different challenges are arising in the field when we are when we are developing AI, and how it requires a team to be set up to ensure safe and proper use of AI is being used at a several large scale. So yeah, it has been a great learning opportunity for me. Thank you for hosting me.
And for the viewers, if you enjoyed watching this stream, we may also delve deeper to Musab's project in the upcoming streams, but that's not a promise. It's just a possibility. And make sure to like the stream and subscribe to the YouTube channel, because we will keep doing these streams on a regular basis. And I hope that you all enjoyed the stream. Thank you for watching. Have a good day.
Have a good day.